Now, this illustration deals with AC systems to be grounded in accordance with 250.20. Now, I would like to point out, so to speak, coming out the gate here, that in 250.20A and B, it addresses in 250.20A systems that could be grounded or they're not grounded. In 250.20B as in boy, those systems have to be grounded. If they're grounded at the transformer, then the grounded conductor has to be pulled to the service equipment disconnecting means and grounded there again. Now, 250.21 says no, the designer and the installer under any of these permissive exemptions here, the system does not have to be grounded. So in other words, in 250.21, you have a choice. In 250.22, those systems cannot be grounded, as we'll see. But keep that in mind as an electrician. You're either having to ground the system of low voltage or you don't, in accordance with 250.20A. 250.20B, you ground the transformer, then the system has to be grounded. If you look at 250.21, you have a choice. Any of those conditions there, you do not have to ground the system. You could, but you don't have to. But 250.22, you cannot ground those systems. Now, we'll look at the three systems, but I just want you to keep that in mind when you're determining where to ground or not to ground the electrical system, and most of all, pull the grounded conductor in where it's used as a neutral or not. We want to make sure that we do that. But now, AC systems to be grounded 250.20B, let's look at the left-hand side first. We have 50 to 1,000 volt system there, and one of those legs could be grounded. And then notice that if you pull 16 amps on L1, you pull 16 amps on that grounded conductor. And it could be a neutral, but it's a grounded conductor. Keep that in mind. And why do we say that when we look at the definition of the neutral? Because it's not pulling imbalanced current. It's pulling the same current as the ungrounded conductor. Now to the right, we're pulling unbalanced current maybe. If you had, say, 100 amps on L1 and 100 amps on L2, then you know from your experience the neutral sees zero. But if you had 100 amps on L1, 80 amps on L2, then the neutral pulls 20 amps. It pulls the unbalance, and the unbalance would be 20 amps in that case. And notice that transformer there is connected to ground, and it regulates the voltage to ground of 120 volt. From L1 to ground, L2 to ground the neutral in this case. But from L1 to L2, we'd say pick up 240 volt. Now, the illustration below that shows a corner grounded system, no neutral. Notice L1, L2, and L3 all have to be the same size. But we're actually grounding the ungrounded L2 leg and making it a grounded leg. So any ground fault that develops will travel back over L2 to earth ground, where it is earth grounded at the service equipment. And we're not going to have a neutral connection at all, but we'll have phase-to-phase current. And notice it's in the transformer section that we reviewed on the systems, the different systems, that is a closed delta system because we have 3 transformers. If we only had 2 transformers, it'd be an open delta type connection. But all we're pointing out here is that AC systems to be grounded in accordance with 250.20, and that's what this illustration 16-14 is illustrating. When is it a neutral, or when is it just considered a grounded conductor as defined for grounded conductor and neutral in Article 100 of the NEC?